Because yeah, I don't know. Mad libs I might use.
We do get prompt.
Get prompt. Oh, okay.
Yeah.
Okay. Well, you definitely use it for silent for sure. Then we'll do like a short interlude where I'll talk about C++ types, and then finally, if we have time, we'll discuss file streams. All right. So I know 106B already covers some basic file streams, so we'll mostly just extend the knowledge of that to file. All right. Can someone check is the recording on?
It's fine.
Good? Alright, sweet. Let's get started. So, just a quick review from last time about these statements. Alright, there are 4 statements, good, fail, EOF, and bad. The key thing to notice about each of these is that when fail, EOF, or bad are on, what happens is that the stream stops functioning. Okay? Any attempt to read or write from that stream will no off. It does not do anything. Okay? So, if you try to just carelessly use cin, what you'll sometimes notice is, okay, it just stops working. It suddenly just freezes and it doesn't work anymore. And we'll discuss why that happens and how would you fix it. All right, last time we got to this point in the code. Does everyone remember this code from last time? This was our implementation of string to integer. And the key idea was we essentially pass it to an iString stream, and then you read an int from it. Now, sometimes you might potentially not be able to read an int, where, let's see, when you try to read ISS alligator result, sometimes that operation might fail, right? If your string is not an integer. So you first check if the operation, if the fail bit is on. If the fail bit is on, like over here, then we just throw an exception. That means what we tried to read in the is not an int. All right, great, thanks. But if it does succeed, we also have to check if after that integer there's any other remaining spare characters. If there are, then that string itself is not an int, so we should also throw an exception there. Okay? Any questions about this code at this point? Yes?
Sorry, what does throw do again?
Yeah, so throw, it throws an exception. It essentially signifies to the user, this function didn't work. And when that happens, by default, it stops the program. It just, the program just crashes. But you can try to catch this exception if you wanted to. Okay. For the purpose of this class, sometimes in functions, you'll see that you sometimes return an error code. But in this case, you can't really do that because any integer that you return might possibly be a valid input. So we can't really return any error message. We have to just throw an exception. Okay. If we don't throw an exception, the user sees that it returns and says, oh, the input must be valid. But the input is not valid, then you have to throw an exception. Yes?
The reason we're checking the second time is just to make sure that there's no string after the int.
Yeah, exactly. So suppose we try typing in 3 lol. Then if we did not have the second check, it would say, oh, you typed in 3, that's a valid integer. But that's not a valid integer, so you have to keep checking if there are any other. Yes, question?
Yes, instead of doing the second check, could we check for the end of file definition?
Yeah, that was actually what we wrote last time, and that works as well.
Oh.
Okay, I think there might be an edge case. I'm not super sure about that. Test it out. I'm fairly sure it works.
Yeah, and another question. Why are you passing the string by reference?
Okay, good point. So in 106B, I don't think they're super strict about passing strings by reference, but I think the general convention is any time you're passing something that's not a primitive, you pass it by reference, and if possible, you pass it by a const reference, which is you don't modify.
Okay.
Yeah. It was covered in 106B, right? Yeah.
And to add on to that real quick, I think Jerry might have said something slightly different in 106X, which is to say that string passed by reference is vaguely a style thing. One of the reasons why we do it is because strings can be of arbitrary length, and so because of that, our preference is to pass it by reference, but follow it for whatever your teacher can pass it.
Yeah. We have a chart later on which shows you all possible cases of parameter uses. So that's a really cool chart. Question? Yes.
What is CH?
CH. You mean CHAR?
No.
Oh, good point. This is probably remain.
Okay.
Yeah. I name it different things. Sometimes I name it trash. Sometimes I name it garbage. Sometimes I name it CH. Question over here. Yes.
Why do we use char remain instead of string remain? That what if there are multiple characters instead of only one characters?
Yeah, so the question is, why do we read a char instead of a string?
Yeah.
I think you can read a string instead as well, but if there is just one character that is after the integer, then we know that the string you typed in is not itself an integer. So as long as we find one character that still exists after the integer, that means our string was not an integer. Other questions? Yes?
What is the greater than boundary?
Yeah, so remember that that's the stream extraction operator. It essentially pulls the next white space separated token out of the stream. Okay? I don't have the animation right in front of me. If you look on the last lecture slide, you can see how we try to read in different like ints and doubles and strings from a string stream, and it reads it one by one through the taking white space separated tokens. Any other questions? Okay, these are great questions. Also, throughout this lecture, I love all your questions, but we also want to get through everything I want to cover today. So I'll try to limit the number of questions if we are running low on time, and then feel free to always ask on Piazza. Okay, Piazza's kind of dead right now. All right, cool. Now, just a small trick that you might see is, this is kind of tedious, where you try to read in something, and then you're like, okay, did it fail? Okay, this is so common that what this ISS CH does is, when it finishes extracting something, it actually returns the stream itself. Okay, so this line returns ISS itself. Okay, does that make sense? Okay, and that's actually why you can chain the extraction operator, because when the first extraction completes, it returns the stream itself, and then you're extracting from that again. That's why you can chain these operators. Okay. Now, if you try to use that as a Boolean, so if we try to do something like this, where we're pretending this itself returns a stream, this will be implicitly converted into a Boolean, which represents if it failed or did not fail. Okay. The more clear way to say it is, these two are equivalent. So look at the code right now and try to figure out how these are equivalent. Okay, ISS, the extraction operator, that returns the stream itself, which is implicitly converted to did not fail. Does that make sense? Okay, so question? Yes?
How does it know to implicitly convert it to stream.fail instead of stream.like when it's checking one of the other bits or something?
That's a good question. So the question was, how does C++ know that this is implicitly converted to stream.fail? So whoever implemented the stream library wrote this thing called a conversion operator, which says, okay, if you ever use the stream itself as a Boolean, then convert it to this Boolean. Yeah, someone wrote that in the library itself. Later on, when we talk about operators, we'll also talk about if you wanted to write such an operator yourself, how would you write it? Okay? All right, so if we use that trick over there, then you can simplify the code into something like this. All right, where you can try reading in result. We're saying that if this fails, or if that succeeds, then throw an exception. All right, and from 106B or X, you've seen while some sort of stream like file, arrow, your character, right? You've seen that being used inside a while loop, and the reason why that works is because that returns this kind of like a Boolean value. Does that make sense? Yes.
So that's a Boolean, or so why is ISS result Boolean?
So ISS, I'm just gonna call it alligator. ISS alligator result, that itself returns a stream. And then a stream, if you try to use it as a Boolean, will be implicitly converted into that stream.fail.
Okay, gotcha.
Yeah. And then why that's the case, whoever implemented the library decided to do that. And it allows you to write some sort of like shortcuts like this. Okay? Any other questions? Let's move on. Let's talk about C out and C in. Originally, I wanted to talk about cout and how buffering works, but let's skip that for now. I'll upload more slides discussing how buffering works, and you can look at it if you want, if you're curious. The key idea is when you cout something, it doesn't immediately print it to the console. It essentially just puts the characters inside its internal buffer. Okay? You have to explicitly flush it for the stuff to appear onto the console. What you've been doing right now usually is you've been using endl. Endl is a new line character plus a flush. Okay, any questions about that? Super short, but that was the main idea of what I wanted to cover. Okay, let's quickly talk about cin. Question, yeah?
Sorry, so quick. Sorry, then are you saying that if you don't use endl, it's not going to appear in the console?
So there are many, if you look on the CPP reference, you'll see there are a lot of different cases where it will flush it for you. For example, if you couted something and then you try to in something else, the cout will automatically be flushed. There are other cases where that might happen, but what sometimes happens is when you write your code, sometimes you're like, oh, it doesn't print. Why is that? And the reason is because cout is buffered. Sometimes you have to explicitly flush it. If you don't see it onto the console, then you can explicitly say flush. Okay. I'll send the code for that. It's really cool, where I essentially write a bunch of cout statements, and then I run like a pause function between them, and you can actually see that not all the characters are printed out. Yes, question.
So that's the difference between the endl and the backslash.
Yes, exactly. Yeah. Endl is a backslash n plus a flush. And actually, some people say that endl is bad because you sometimes flush even though when you don't need to. Okay. For me, it's just really natural for me to type endl rather than try to figure out where the backslash character is. So I just use endl. Yeah, question.
How do you flush if you don't want to use endl?
Yeah, good question. Essentially, instead of endl, like arrow, arrow, endl, just do arrow, arrow, flush. Yeah, that will flush the string. All right, let's go on. Let's talk about this cout and cin. Cout and cin work the same way as string streams. The only difference is that we now actually have a source over here. And because there's this sometimes when you write it into the buffer, it has to read or write directly to the console. That will be a source of error that you'll see in cin. Okay, so let's quickly talk about the file streams. No, not file streams, IO streams. Cin is the standard input stream, and then there's also 3 output streams. Okay? The main difference between these is some of them are buffered, some of them are not buffered. Okay? And depending on how your console is used, sometimes these appear in different colors, sometimes they're in different consoles. In mine, I think all of them show up on the same console. Cool. Okay, that's about cin. So let's write a really short program right now. Oh, okay, I did the wrong thing. I should not, okay, remind me next time to not exit the thing. Let me start the video. 5 seconds. Okay, so let's write, actually let's not write the program, I've already written it for you. So, here's the program. So, it's a pretty innocuous program. Maybe let's turn off one more light. Like this. Oh, zoom, yes. Okay, can everyone see? Larger? Anyone want to make it larger? Okay. So you can see right now what the program does is it asks the user for your name. Not update this code correctly. And then you try to read it into it. Then you ask, what is your age? And then we try to read it into an age. So finally, it reads where are you from, and then it tries to read into a string of where you're from. Okay, and then it says later, hello, name, age, whatever, from whatever home. End. Okay? Seems like a pretty innocuous program. Let's try running this. G++, C++17, cin fun.cpp.o cin file. Oops, forgot to return. Oh, forgot to return 0. We're gonna write that function later, and then let's return 0 here as well. Okay, let's run that one more time. Access. Okay. Oops, not access. Cin fun. All right, what is your name? what's your age? 20. Oops. Let me try that one more time. I was not supposed to type into the dash. Try that one more time. Avery, 20. I'm from Taipei. Okay, hello Avery, age 20 from Taipei. So everything works perfectly, right? Okay, let's just quickly go through how that went. Alright, just run this one more time. Okay, and then this should be slideshow. Okay, so let's go through how that program ran, right? So cin name. Now the difference between string streams and cin is that what cin does is if there's nothing left in the buffer, it will essentially pause and wait for the user to type in something. That's when the user gets this prompt that says, okay, type in something. All right, so you can see EOF is on because there's no more stuff in the buffer, and when that happens, it pauses. When the user finally types in something and presses enter, like this, then the stream tries to read in a white space separated token into name. So here it tries to read in a string, Avery, and it puts it into name. Now, this next line, what cin does first is it skips over any new line characters, any white spaces. And then it sees, oh, there's no more characters. Let's try it. Let's prompt the user again. And then now I type 20. When you type 20, it reads in whatever you typed. Here we try to read into an integer. So it tries to read in an integer that it succeeds, and it puts 20 into H. Here now we just print name and age, so we print 20. Finally, we print some sort of response. There's nothing left in the buffer, so we try reading from it again. The user is now prompted, and then we type in Taiwan. It reads into Taiwan and Taiwan. Okay, does that make sense? So far, so good?
Why did yes?
Oh, I forgot to modify it, yeah. Before it was like response, do you want to play again? But then I thought, oh, this is more interesting. Okay, any questions so far? Yes?
Why is there no slash name between Avery and 25 now?
Why is there no backslash n here? Good question. So, because when we print right now, we don't print like a new line character. We don't print backslash n or an endl, so it doesn't actually put it onto a new line. Okay. The other ones have a new line because the user actually pressed enter themselves. Yes.
What happens if whatever you type in does not match the type of what cin is going to? Like if you type in a string and when it asks for your age or something like that?
Great question. Before we get to that, any other questions about this slide? Because that's the very next slide.
Okay.
Okay. Yes.
Yeah, just with cin, if you gave your first name and surname, what would happen? Does it take in both? Or?
Great question. That is the very next slide. Okay. So yeah. So you can hear there are two sources of errors, right? One is, okay, what if I typed in my full name? Seems innocuous enough. Other question is, what if I type in the wrong type? Like for age, I don't type in an int. Let's see what happens when streams go wrong. So let's try cin fun. Let's just say I type in my full name. Okay, look at the output. Is it large enough? Can everyone see the output? Okay, talk with your partner right now, or the person next to you, for 30 seconds. Don't try to figure out why this happened. Figure out what happened here. Like exactly what symptoms do you see? There should be 3 things that you notice. All right, so, okay, so you don't have to explain why this happened, just what are some observations you noticed about the output? Any observations? Yes.
Got the 0 value for the age. Like,
Yeah, age is 0, right? We never typed in any age. Yeah. More importantly, it skipped all the other prompts. Right? Okay, it printed out the prompts, but it never actually asked us to type in more stuff. It skipped over them completely. Any other observations?
Missing Wang?
Yes. Notice that I typed in my full name, but it only gave me my first name. Any other observations?
Missing a default for where are you from, or maybe the blank space is the default.
Yeah, so notice that it gives me 0 and some sort of empty string probably over there. Right? The key thing is it never asked me what my age is or where I'm from. Okay, let's try to visualize this. So here I type in my full name. Now remember what cin does. Well, first cin notices that the buffer is empty. So we prompt the user to type in something. I type in my full name. What cin does is it reads up to the next white space character. Just like a string, it reads up to the next white space character. Okay, so it reads Avery into name. Now what happens at this line? Cin age. Okay? The buffer is not empty. And because the buffer is not empty, we don't try to read in, we don't ask the user to prompt for more input. We essentially say, okay, there's more input, let's try reading that into age. Okay, but that's obviously not an int, so that fails. What happens when it fails? Notice that the fail bit is now on, because we were unable to read in it in int. And what happens when the fail bit is on? All future operations don't work, right? All future operations don't work. So because the fail bit is on, that fails. Okay, we still try printing some stuff, and then this fails. Okay, any questions? All right, so 3 reasons why the alligator with cin is a nightmare. First reason is it reads the entire line into the buffer. Right, so when the user is prompted to type in something, it reads in the entire line. But when you actually try to get the character from it, it gives you a white space separated token. Second part is there might be trash inside the buffer, which makes it so that the user is no longer prompted. In that example, Wang is still in the buffer, so we never prompt for age. And thirdly, when cin fails, all future operations fail. All right, this just seems to get worse and worse and worse. Yes, question?
Can you say 1 again? What does that mean? That it uses the white space separated token?
Yeah, so when we try, when we prompt the user, if I type in my full name, it moves my full name into the buffer. But when you actually do the extraction operation, it reads in white space separated tokens, right? Those things don't match. So which is why if you type in a full line, you won't see that full line appear. Question, yeah?
Yeah, Avery, just to clarify, so what you mean with point 3, all future operations, that means all future cin operations, right?
Yeah, yes, all future cin operations, yeah. Okay, if you're using many streams, then cin specifically fails.
So how do you get a full sentence from the user?
Good question.
Okay.
That's our next slide. I really love your questions. You're always predicting what's coming next. Yeah, question, yeah?
So what if age was a string?
What if age was a string? Okay, good question. So if age was a string, then we would be able to successfully read in Wang as the age. So it would move that into here, into there. So in which case it would still work, but these 2 cin operations, only the first one will prompt the user. So I type in actually, let's just write that out. I'm actually curious what's going to happen. So let's try writing that out. That's a good question. Let's change this to string. Okay, so notice that it skips prompting for age, but it still prompts everything else. Okay, let's say it reads in Avery, and then it interprets the second white space token as age. And then only now, when the buffer is empty, now I prompt for something next, for type A. That's where this comes in. All right. Okay, so that's kind of annoying. What can we do now? So the key idea is we want to read the entire line. right? When we move something into a string, we want to be able to read the entire line, not just white space separated tokens. From CS106B or X, there's a method which lets you read an entire line from a string. Yeah. So get prompt from user is a Stanford library function, but it doesn't just get one line; it gets like a whole bunch of. It gets a file name. Yeah. Getline is actually is not a Stanford library function. Getline lowercase l, that's actually a C++ function. What it does is it reads an entire line up to the backslash n into a variable. Right? So how it works is getline, we put in cin, what we're reading from, name, the variable that we want to read in the entire line to, and backslash n, that means read up to the backslash n. Now, in this case, when you've used getline, you don't use the backslash n because that's an optional parameter. If you ignore that, if you just leave off the backslash n, it still works the same way. Okay? So when we write this instead, it reads in Avery Wang as an entire string up to the backslash n, and it moves it into the maker. Question, yeah?
Is there any way to make it so it goes like until it reaches the end of file getline?
End of file getline. Is there a way to read it so that it reads up to the end of the file? We haven't talked about file streams yet. Let's talk about that later. Okay, yeah, but yes. Well, depends on if you're reading it line by line or the entire thing at once. Depends on how you want to read it. Other questions? Yeah.
So it's like the final parameter you put in, like let's say you put in a period, but you don't have to a period until the end of the file. Will it keep reading like different lines until it reaches the period, or will it stop at the end of the line?
So this will stop when it sees a new line character only. So periods don't matter. It only stops when it sees a new line character.
No, like if you change the parameter, like you change the third.
Oh, okay. Good point. So if you change that to a period, then it reads up to a period.
Okay.
Yeah. Now notice that the new line character is not actually part of the string. It reads up to that character, but it doesn't include that character. Any other questions?
So what if it never finds the character?
Sorry, can you repeat the question?
What if it never finds the character you put in, like the parent? Like there is no, for example, you put a period in this case, you never find that. Will it read the whole buffer?
Yeah, good point. So if you do that, then it won't read the whole buffer. It will read up to the period and it stops. Question, yeah?
What if you change that to a period, but there was no period?
Then I think it reads up to the end of the buffer. Then it says, oh, there's nothing left. So.
And the spec will actually say that as well, with two different like entities in the spec.
Key thing to note, you can only read in strings. You can't read in an int or getline.
Instead of, are there alternatives to cin?
Alternatives to cin. If you want to read from like the standard input, like whatever the user types, that cin is the stream that you use. Yeah.
You could also go like file.
Good question. So I think your question is, can you do any other streams?
Right.
Yes, you can do any other streams. You can do.
So the first parameter is a string, and then the
Yeah. Yeah. So in CS106B, just a tip for the exam, you'll probably get a question for 106B or X, which is you have to essentially process line by line, but each line has like different items to it. How you want to do that is you want to read it line by line, and then given one line, how do you separate the tokens? Use a string. Right? Once you have the one line, then you can separate it using a string, which we'll do later. Alright, so C in H, we can't change that right now. Let's just keep doing that. And then everything else works so far. And then response, because response is also a string, let's do getline so that works. Okay? Now, this doesn't work, and I don't want to demo it, but notice what happens to this getline call. The user is actually not prompted. When this call happens, it reads in the backslash n as the string inside response, so the user is never prompted. Remember in 106B or X, you're explicitly told never to mix the arrow operator with getline.
I don't think we were told that.
Does the people cover that? Huh.
No.
Did Jerry cover it?
Not yet.
No? Soon on assignment 2, you will all run into this problem. Like, trust me, you'll all run into this problem. And then when that happens, just remember, don't mix that with getline. Okay, now, how would you solve that though? So back here, right? How can we solve this backslash n question? So the code is this, but this doesn't work because it reads in backslash n. Yeah.
You like make cin move one character?
That's a great idea.
Flush
So
the buffer or emblem.
yeah, so there's a command called cin ignore, which just ignores one character. So that would work. Last time we mentioned more methods about how you can like manually reposition. You can also use any of those methods. Okay, this is the simplest one. And what that does is it ignores one character, and then when it says get line, the buffer is empty, so it tries to. Yes, question.
I still don't understand why it fails when between, like, why getline and the alligator fails.
Yeah. So what the alligator does is it reads, like for example this one, the alligator reads up to backslash n, but it doesn't consume backslash n.
Oh. But before it did. The previous getline did because you already.
Yeah. So what the alligator does is initially it skips all white space characters, including the backslash n, and then it tries to read in whatever you are reading up to the white space, but it doesn't move past the white space. It just reads up to the white space. So for example here, getline. Yeah. So getline reads up to here. cin will skip all the initial white space, then read the 20, but it won't move past the white space. But it won't move past the backslash n.
Okay.
So when you try to do a get line over here, it will read in backslash n. Okay, backslash n, get line and the alligator, they don't mix well, unless you do something like this. So just an FYI, if you ever run into this problem, you can just skip a character. All right, let's see. So we fixed some of the problems. Now, if I enter my full name, everything works. But there's still a problem that you'll see over here, and that is the second problem you mentioned. If we try reading an integer, but if that doesn't work, then what do we do? So suppose I type in 20, well, that won't work. So here's now where we want to try to write a function called getInteger, which will do the arrow tag for us. Okay. The code we'll write right now is literally the standard library getInteger function. All right? I think that is probably one of the toughest functions to implement in the standard library, and we're going to do that right now. What time we got? Oh, out of time. That's okay. We can skip file streams. All right. Let's do. I think it's in C in fun.c. All right. So we're given the prompt and the reprompt, and let's try to write this function. Okay. So getInteger. Recall what getInteger does. What does getInteger do? Yeah.
Asks for an integer, checks whether it tries to put the input into an int variable, then checks either if it's the end file or if there's another character, and if there is a reprompt.
Okay, so the important part, the first thing I want to talk about is reprompting. So if the user types in something that's an integer, great, return, we're done. If the user types in something that's not an integer, you have to reprompt and then essentially try the whole thing again. Yeah, so what does that suggest what we have to write here?
While loop.
Yeah, we need a while loop. We have to keep looping until the user types in something proper, then we can skip out to the while loop. And I'm going to use Jerry's favorite loop, while true. Okay, so let's just do a while true loop, and then let's prompt the user. Prompt. Okay, so the user has been prompted. How do we read in something from the user? Getline, yes. We want to use getline here. Let's read into line, and then we use getline and we read into it. Okay. Now, one thing you always want to make it a habit of is getline returns a true or false value. Okay, it actually returns the stream, which is converted to a true or false value. It returns a true or false like value, which represents if it succeeded or not. Okay, so you always want to check, okay, did that succeed? If it did not succeed, then you want to throw an exception. Throw, something happened. Okay? All right, now that we have one line, so we have a line that is the the string representing the int. How can we read the int now? Yes.
An int string?
Put it into a string.
An int string.
An int string. Let's see. I'm not sure what an int string is.
Or wait, I don't know. I just was looking at the last lecture slides. There was something about that.
String to integer.
Yeah.
Oh, okay, yeah. So last time we wrote a function called string to integer,
Okay.
which
used an input stage.
yeah. Let's just do the exact same thing we did for the string to integer. The only difference is string to integer, it throws an exception if you didn't type in an integer. Here we want to reprompt if it doesn't, if we did not type in an integer. So let's do we'll create a string. This is what we did last time. Turn it into a string, and then what do we do here? Yeah, so we tried reading it into an int, so into val, and then don't forget we want a remain. We want the first operation to succeed, so if the first operation fails, or if the second operation succeeds. Oh, actually, we want if the first operation succeeds and the second operation fails, then that means we succeeded, right? The first operation succeeded, that means we typed in an int. The second operation failed because that means we tried reading, there's nothing left after the int. So in that case, we can just return the value that we read in. Question, yeah?
Would it be okay if the user just typed in a bunch of spaces and then an integer, right?
Good question. So if the user types in a bunch of spaces, that might make this a little off. I think what the getInteger function in the Stanford library does is it ignores some white space. I think it ignores white spaces in the beginning. Yeah, they'll test it out. Correct me if I'm wrong, but I think it ignores white spaces at the beginning. Okay. And then if this if statement doesn't work, that means what does that mean? That means our attempt to read in an integer failed, so we just reprompt over here. Okay. This is kind of like what we did last time in string to integer, except the only difference is instead of throwing an exception if it fails, we're going to reprompt and we're going to just keep running inside this loop until we're done. Okay. Missing anything? Yeah. The slides go through another way. This is how Google recommends it. If you look at Google's C++ lessons, they recommend this, which I think is disgusting. Yeah, essentially what it means is it says cin.clear. Cin.clear is useful if you want to reset your stream so that it's in a good state right now. Because before it was fail, right? Before it was now it's fail, but then once you clear, it becomes good again. All right, and then what this monstrosity does is it skips as many characters as possible so that the buffer is empty. Okay, so it skips to the end. I don't actually want to talk about this because, I mean, why would you do this, right? But
why don't you just clean the whole buffer?
Yeah, but then the way to clean the whole buffer is to do this. Yeah. Now
It
what?
doesn't just move it ahead. It doesn't actually forget it from the beginning. I mean, this is still in the memory, right?
Yeah. So what this does is it moves the buffer as much as possible, and the stream itself recycles its memory when you pass too far. Yeah. Question? Yeah.
What does cin.clear do?
Cin.clear it resets the state of the stream. So before here it was in the fail state. Remember that if it's in the fail state, we can't do anything much with it. So to clear that, we want to call this function to turn it into good. Notice that clear doesn't actually clear the stream itself, which is kind of a bummer. Okay. So yeah, I don't know. Google recommends this, so I guess you should do it. But Stanford recommends this. So I think this is much more elegant. All right. Yeah. Just a quick overview of what this does. We're essentially creating a separate buffer where we're doing the processing in that buffer instead. Okay, so let me just walk through this. We try to read and get line, so we read that whole line from C in. We create another string stream with that same line, and then we try reading in an int, and then we also try reading in more trash. Okay, so it successfully read trash, so this fails. Okay, and then here we actually don't need these lines because we're creating a new iStream stream every time. Right? So we can actually remove these. When the function ends, so like when you, if I type in this number, every iteration of the loop creates a new ISS, so we don't actually have to clear the ISS. Does that make sense? I'm skipping through this a little fast, but
Does it forget its previous ISS?
yeah, because when ISS goes out of scope, because the scope of ISS is within the loop, so once it goes out of scope, the ISS is gone, and it creates a new one every iteration. Questions so far? Alright, we have 10 minutes, and I want to quickly talk about types, because types are fun. Alright, and then file streams, if I have time next time, I'll steal 10 minutes of Anna's lecture. Okay? Quickly talk about types. Types are cool. This is like a, let's make this 10 minutes. 10-minute crash course. I'm not going to go super in depth, and I'm not going to do any code. Well, there will be code on the screen. So, bear with me. So, sometimes the STL will use gigantic names. Okay, this is one of the types we'll be dealing with later. STD unordered map of a full list of a student, which is mapped to an unordered set, and then we want the iterator of that something. Okay, so sometimes we'll see this. So and a lot of times in the libraries we'll be using this thing called a name alias, which is a type alias where we're essentially defining that type to be a shorter name. Okay, so sometimes in the libraries you'll see map iterator instead of that gigantic type, and the reason is well because the type is simplified. Now this is still error prone because this code actually doesn't work. Technically, yeah, so you can replace it like this. Technically, the type here is a const iterator. We'll talk about that next week. But to prevent small errors like this from happening, C++ 11 introduces this new keyword called auto. Okay? What auto does is essentially says, compiler, figure out the type for me. So, the compiler looks at that thing, and it figures out what the type of that thing is.
It's like var.
In JavaScript?
Yeah.
Think so?
Yeah, same idea.
Okay,
Same
yeah.
idea. And this is another example of C++ like adapting to other popular features of other languages. So sort of like how other languages.
One cool thing in Qt Creator is if you hover over the auto, it will tell you exactly what the type is. Cool, right? Alright, so auto, you can,
Before runtime.
before, yeah, so this is actually a compile time thing, right? Auto is a compile time thing. Auto can be used in a lot of places. So for example, here, what's the type of copy?
Vector of string.
Yeah, so V is a vector of string, so when you copy it, it's that type is a vector of strings. What's the type of this? A double. What's the type of this? Okay, trick question. This is a C string, so it's a char star. But don't worry about that. The better way is to say, okay, this is a string. Now, something to know is that what auto does is it discards any references. I haven't talked about references. I'll do that next. One final thing is we'll see these cool weird things here. This is called a Lambda function. And when we talk about this, one cool thing is you don't actually know what the type of this thing is. Okay? The compiler names the type for you, but you don't actually know what the type is. So here is where you have to use auto, because there's no other name that actually makes sense. You don't actually know what the name is for the type. Any questions so far?
Why don't you know the name?
Because, so what this does is the compiler actually creates a new class for you, and it creates like an instance of that class. But what the compiler names the class, you don't actually know. If you don't understand what that means, don't worry too much. Basically, you can't figure out the type. There's no way you can figure out the type. Just ask the compiler to give you the type. Questions? Yes?
Why would you need that?
We will use this in week 4. Yeah. This works just like a function, but it's used in special places in week 4. You can also use auto as a return type. I don't recommend this, and I'll explain why later. One important thing is you can't use auto as a parameter. Alright? Just something to keep in mind. Why should you use auto? Well, first, it offers a lot of like correctness benefits. Just like the bug we saw before when the const iterator versus the iterator, asking the compiler to figure it out for you is like the compiler won't make a mistake. You might, but the compiler won't. So you won't get issues like implicit conversions, trying to convert an int to a double to an int, for example. And you also won't get uninitialized variables. It's also flexible. If you ever need to change the type, well, auto makes it easy for you. Now, when auto should be used is a very contentious topic. All right, there are two camps. One camp is called AAA, almost always auto. The founders of C++, they support that camp. On the other hand is people who hate auto, and I'll tell you, most of the section leaders are in that camp. Okay, so quick question: should you use auto in 106B?
No.
No. Do you agree with that?
Absolutely.
Okay. Yeah. Most section leaders don't like auto, and there's one instructor, Keith, who loves auto, and the section leaders start arguing with Keith when that happens. So I recommend don't use auto. Okay? You might get like a, where did you learn this? Why are you using this from your section leader?
Fun fact for that, Keith was the person who actually founded CS106L, so that may explain why he likes auto. And now you guys will all like auto, so.
For example, one place where you should not use auto is like a return type, because if you see this in like the standard libraries, if you see this function, you don't actually know what it returns, right? Like splice string, it could be a vector, it could be an array, it could be a string, for example. So I don't actually know what this is. So I recommend the headers don't use auto in the header. How much time do we have left? 4 minutes. We can get through this. Structures. I don't really want to talk about this. Okay, structures. Normally in 106B, if you want to return multiple things, you can't do that. Okay, this is my favorite topic because the most common question in 106B is, how do I return multiple things? Okay. And I think Cynthia did an example with like lottery numbers, and you use reference parameters to pass them different values out. But that's really unnatural, because if you look at like this line, how can you tell that min and max are reference parameters? It's not super obvious. It's more natural if you just returned something, if you returned both values. So C++ 11, actually I think it was before C++ 11, but you can actually return a pair. For example, you can return a pair of integers. And then when that happens, you can essentially, you now have a pair of integers, and you can reference them by p dot first or p dot second.
Was that triple?
A tuple, yes. C++ 11 introduces a tuple, which is an arbitrary number of elements like that.
Cool.
Okay. What's one? Oh, so pair int kind of cumbersome. Use auto here. Even better, this is stolen directly from Python. Okay. So sometimes it's nice to get a pair and then immediately unpack them. Like here, you want to immediately unpack min and max. Right? So instead of doing this weird thing where you say p dot first and p dot second, you can immediately unpack it so that you get min and max immediately. This both declares the variables and it also assigns them to the first and second values of the return element. Okay? Yeah, question?
How much more memory intensive is this than just passing in parameters by reference and assigning them?
I'll show you a chart later, but not really, because the 106B reason why you shouldn't do that is 106B, by the way, we don't have time, so I'll just skip to the end, but cover this later, blah, 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 blah. Oh, here. Okay, so here's a chart. This is when to use each type. So there's a couple kinds of parameters. Out parameters is what we just showed, where you are essentially creating stuff and passing them out. All right. The preferred style is to use the return value. Okay, and then just a side note, 106B prefers that instead. The reason why 106B prefers that is because in 106, using modern C++ compilers, return values are often optimized. So when you actually return like a vector, the compiler actually makes it so that you don't actually return the vector. You don't create a copy of the vector. Okay, so modern compilers have this thing called, I think I've written on here, return value optimization, RVO. We'll actually talk about that a couple weeks later. But feel free to return stuff in modern C++. Okay? You won't get like a huge performance issue. Other things, in-out parameters, you have to use a reference parameter. That's how reference parameters work. And for this is also what 106B and X use, where if you're passing in like a collection, which is relatively large, but you're not modifying it, you pass it in as reference. But if you're doing primitives, you pass it as a byte value.
Is there any other benefit except for security?
for that. So C++, remember one of the philosophies is express intent. So C++ programmers, they know this part. If they see a const reference, they know that that is an input. If they see a reference like that, they know it's an input. Okay, this is like a contract. If you are saying this is a, if you use this, they will be careful about what they're passing because they know.
So this
This detail also on the slides. In week 9, we'll talk about this cool thing called loop semantics, where you'll see these double references. Ooh.